Welcome to this video on total internal reflection, one of the most fascinating phenomena in optics. This concept explains how light can be trapped inside materials, which is the reason behind the sparkle of diamonds and the working principle of fiber optic cables that power our internet connections. Total internal reflection is a special optical phenomenon where light traveling from a denser medium to a rarer medium gets completely reflected back into the denser medium. What makes this remarkable is that 100% of the light is reflected, meaning no light escapes or passes through to the other side. This is different from regular reflection, where only some light bounces back. For total internal reflection to occur, two conditions must be satisfied simultaneously. First, light must travel from a denser medium to a rarer medium, which means from a material with higher refractive index to one with lower refractive index. Second, the angle of incidence must be greater than a specific value called the critical angle. Only when both these conditions are met will total internal reflection take place. The critical angle is the minimum angle of incidence at which total internal reflection begins to occur. It can be calculated using the formula sin of theta c equals n2 divided by n1, where n1 is the refractive index of the denser medium and n2 is the refractive index of the rarer medium. This formula only applies when n1 is greater than n2, ensuring light travels from denser to rarer medium. Let's understand what happens at different angles of incidence. When theta is less than theta c, normal refraction occurs and light exits into the rarer medium. When theta equals theta c, the refracted ray grazes along the boundary between the two media. But when theta is greater than theta c, total internal reflection occurs, and all the light is reflected back into the denser medium. One of the most important applications of total internal reflection is in optical fibers. These are thin strands of glass or plastic through which light signals travel by repeatedly reflecting off the inner walls. Because of total internal reflection, light stays completely trapped inside the fiber and can travel over extremely long distances without escaping. This enables high-speed data transmission, forming the backbone of modern internet and telecommunications. Diamonds are famous for their brilliant sparkle, and total internal reflection is the physics behind this beauty. Diamonds have a very high refractive index of about 2.42, which gives them a small critical angle. When light enters a diamond, it undergoes multiple total internal reflections inside before exiting. These repeated reflections create the dazzling sparkle and fire that make diamonds so captivating. Let's summarize what we've learned. Total internal reflection occurs when light travels from a denser to a rarer medium at angles greater than the critical angle. In this phenomenon, 100% of light is reflected back with no transmission to the other side. This principle powers fiber optic communication systems that connect the world and creates the mesmerizing brilliance we see in diamonds. Understanding total internal reflection helps us appreciate how light behaves in different materials and how we harness it for technology and beauty.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.